Okay, let me open clips also. So last day we have discussed about the inheritance one, and then we have seen abstraction. So what is abstraction? To hiding main implementation, we'll use abstraction concept, right? So with the help of interface and abstract class, we can achieve abstraction. Okay. So now we'll see what is abstract class, what is interface and all. Got it? Let me open this in Paint. Right, so we have seen like we have person 1, we have person 2. So if you want to call person 2, what is the internal process? First we'll type this number in your screen, right? You press to that call button, then internet, it will go to your nearest network, then it will find, okay, where is that nearest network for person 2, then it will then person 2 will get call from person 1, right? So this is the internal process. So when you click to that call, so just assume this call is what? This call is one method. So somewhere that method implementation over there, right? So just you are using that method. So we are hiding those implementation in different class, right? So we are just calling that method, but main implementation is available in somewhere else, right? So that is abstraction, to hiding their main implementation. So abstraction is a process of, let me add someone. So abstraction is the process of hiding the main implementation details and showing only functionality to the user. So you are using this call functionality, right? So once you are clicking to that call button, you are able to talk to that person, right? Whoever you are calling. So that is abstraction. So just you are using that functionality, but their main implementation, all code written somewhere else, right? So now we'll see. So with the help of interface and with the help of abstract class, like in polymorphism, we have seen how can we achieve polymorphism with the help of method overloading and with the help of method overriding, right? In polymorphism, we have seen that like with the help of these two, we can achieve polymorphism. The same way, with the help of interface and with the help of abstract class, we can achieve abstraction, right? Now one by one we'll see what is this interface, what is this abstract class. Got it? So first we'll see abstract class, then we'll go for the interface one. Or what will, okay, first we'll see the interface one. This is the small one, abstract class is the big one. Let me take that. Yeah. Clips open now. Okay, so we have discussed this program earlier. So for inheritance, we have this one. We'll create one more package here for abstraction one. So click to, just right click on that. Now we'll create one package com.dummies.abstraction. So in abstraction package, we'll discuss only abstraction type of program, right? Let me create one class as well. Right click, go to new class. Abstraction example. So here we'll discuss two topics. One is interface, another one is abstract class. Alright, interface and abstract class. So what is this interface? Right, like why will use interface? So because we have to achieve abstraction, so that's why we will use interface on that, right? So how can as we are creating this class, right? So what is the syntax for that? We are writing this class keyword and then we are writing class name. Okay, the same way, right? If you want to create any interface, so what you have to do? We have to use interface keyword. So interface is one keyword in Java, right? If you want to create any interface, you have to use this keyword. As we are using, if you want to create any class, what we are using? We are using this class keyword, right? The same way, if you want to create any interface, you have to use this interface keyword. Interface and then your interface name. So I'm just giving interface I1 or anything you can give. You can give example as well. Example, any name. So I have created this interface. So you have to use this keyword here, right? So what is this interface? You can say interface is a blueprint of a class, or you can say static, constant and abstract method. So inside interface we can declare only declaration. So inside interface we have only declaration, right? Not the implementation. I'm giving example for that one. So see here. So this is interface, okay, and this is your whole implementation class. So this is interface and this one is your implementation class. Okay, implementation, yeah, sorry, this one is your implementation class, right? So whatever you have, so just assume we are trying to we have one car, right? Inside car we have different functionality, right? So just assume we have one car. So we have this car. So this car. So we have one Tesla car. So inside Tesla car we have different functionality, right? What type of functionality? So we have drive functionality, right? We have brake functionality, we have some window also, window, wheel, right? And gear, some music system is there, and so on. Okay, so we have these type of functionality in this Tesla car. So what we are trying to do, if we want to add some functionality to this Tesla car, what we'll do? We'll use this interface. So as we have discussed, in interface we have only their declaration, right? So if Tesla want to use these feature in their car, what they will do? They will use this interface, okay? But their actual implementation available in which class? In this class. So we have that method public drive, sorry, public, or if we have any return type we have to give that one. So as of now, yeah, I'm giving this void, okay? void drive. So if Tesla car wants to use this drive feature in that car, right, they will use this drive method. So their implementation is there. Where is that? Yeah, see. So if Tesla car wants to use this drive feature, they will directly not call this method. As we have seen, if we are creating any class in same class, we are creating that method and we are using it, right? But if we want to use abstraction, we won't be like, will not call directly that method. If you see here, we have created this abstract example class, right? So if we are trying to create any method, right, so we'll directly do what? Void drive, and sys out, I'm writing some statement. So this is drive functionality. Okay, so if you want to use this drive method, what we'll do? Let me yeah, so first we'll create object of this class, because this is non-static method, right? So obj equal to new, and then we have created object of our class. Now we'll do what? Obj dot drive. Simply we have run, if we'll run that program, we'll get the output. So here we are doing what? We have created that method in that same class. So if we are calling that method, it means we are directly hitting that functionality. We are directly calling that method where we have their implementation, right? So directly we are calling that implementation. But what is abstraction saying? We will not call direct their implementation. So we'll hide this whatever functionality we have, we hide those implementation. Okay, so we'll create some blueprint for this one, right? And we'll use that blueprint for that. So actual implementation is available in different place. So you have your original Aadhaar card, right? So if some if you are filling any form, and if you are going somewhere for giving any exam, or for example for somewhere, if you have to submit some document, right, you are not submitting your original Aadhaar card, right? You are taking printout of that Aadhaar card, xerox copy of that, then you are submitting that photocopy, right? The same way, see here, this one is your original Aadhaar card. So if you want to use this abstraction is that one, you are not using your original Aadhaar card in this place. You are doing what? You are taking printout of that Aadhaar card, then you are submitting that document, right? The same way, we are not going to call that method directly. Will make a copy of that one, and we'll use that copy one. So that way we can achieve abstraction. Okay, so just see here. So we have this interface. So inside this interface, we have declared these methods: drive, brake, window, wheel, gear, music into that, right? And the main implementation available in which class? In this class. Okay, so drive is there, then just I'm writing method name. Okay, drive, brake, and their implementation. Okay, then we have window and their implementation, then wheel, and then gear, and then we have music, and so on. So just I'm writing some functionality here. So see, if Tesla wants to use these method, brake, window, wheel, gear, music, they will directly not call this one. First they will go to interface and they will use that one. Got it? So we are not calling our main functionality directly, we are hiding those details. Okay, we are calling, first we'll call this interface, then interface internally will go to this method. Got it? Now that by program, we'll see how it works. Okay. Okay, so abstraction example, right? I am just removing this one. I'm removing this one as well. Now, what we have seen, so first we'll create this implementation class. Okay, so we'll create one class here, class car. Okay, now inside this class car, we'll create some method. Okay, so public void drive method. So in implementation, just I'm printing that one, right? So this is drive functionality. Okay, now copy. Second is gear, and then we have window. This is window. Then we have music. Then we have wheel. Then we have wheel. Then we have brake. Then we have, okay, brake is one keyword. BRK. Okay, brake. All right, so we have these functionality in our class, in Tesla car. Okay, let me rename it with Tesla car. Okay, so in Tesla car we have these functionality, right? Tesla we have remove this one. Yeah. Okay, so what we have seen, if Tesla wants to use these feature, right? They will directly not use these method by creating Tesla car object. What they will do, they will go to interface, and interface will use these methods, right? So we have seen inheritance concept earlier, right? So if we have any class, what we are doing, if we want to use this Tesla car property in this class, right? Wait, I have one call. हेलो.
हेलो.
हाँ भैया, मिंत्रा से बोल रहे हैं.
हाँ, मिंत्रा मिंत्रा से.
आगे आगे हैं, बस आ रहे हैं. ठीक है. I will be back in just 2 minutes. I have to collect one parcel. Just wait 2 minutes. I will be back in 2-3 minutes. Yeah, sorry for that. Okay, so we have created this Tesla car class. Inside this Tesla car class we want to use these functionality, right? Brake, gear, window, music, wheel and drive. So with the help of abstraction we want to execute these methods. Okay, so what we have seen, so if we have created our class, inside our class we have declared our method, so we'll not call these method directly. So with the help of interface we'll do that. Now earlier we have seen that inheritance concept. So if we have any class, let's say we have class A, we have class B. Class B wants to use A property in class B. So we'll use what? We'll use inheritance and we'll inherit class A property in class B, and then we'll use that method, or what, like whatever method or variable you want to use, we'll use that one, right? But when we have this interface, and when why interface came into this picture, right? So interface, right? So I have created this interface I1. So when we are creating any interface, okay, so inside this interface we can only declare methods, okay, not the implementation. So implementation will be in different class, in this Tesla car class, but in this interface we have only their declaration. So whatever method we have created in this Tesla car class, we'll just declare those methods in this interface, okay? And if we want to use these methods, these music, these field, these break, what we'll do, we'll use this interface. So we are just let me create these methods. So where is that one? Yeah, so public void break, no, first one is drive. Okay, public void window drive gear window. Okay, public void gear, public void music, public void wheel, public void, okay, oh, not this one, brek. Let me click to that next. Oh, why am I writing this one 0 here? Yeah. So if you see here in this interface we have declared those methods, okay? So we have only declaration in this one, and our implementation is available in which class? In this Tesla car class, okay? So if we want to implement, so first we have interface methods implementation available in which class? In this Tesla car class. So if we want to use these methods in this abstraction example or any class, any different class, what we'll do, we'll implement these methods in this class, right? So we have to use implements keyword for that, and which interface we want to implement, we'll use that one, I1. So our interface name is what? I1, right? You can give any name, as we are creating any class and will give any name into that, you can do that same, right? So we have created this interface I1. Inside this interface we have created these methods, okay? Those methods implementation available in which class? This class. So we have to specify, okay, that interface methods implementation available in this class. So that's why we are using this implements keyword. So if you compare inheritance with this one, right? So if we're trying to, so just assume Tesla car wants to inherit I1 class property. Just forget that this one is not interface, this one is class, right? So Tesla car wants to use I1 class functionality in this class, right? They will do what? They will do Tesla car extends this class name, right? The same way, when we'll come to interface, Tesla car wants to implement this I1. So I1 method we have, I1 interface we have only declaration, not the implementation, right? So that's why we are writing here Tesla car implements I1. It means Tesla car wants to implement those methods whatever we have declared in our interface. So we have declared this drive methods, but only declaration is there in I1. So our drive implementation in this class, gear implementation in this class, window implementation in this class, music implementation in this class, right? So if you see, if I'll remove this one, right? I have just removed this. I have removed all the method that I have created in this Tesla car class. It is giving any error. What error? So see, the type Tesla car must implement the inherited abstract method, this one, right? So whatever method we have created, method we have mentioned here, we have to implement those methods in this car class. Got it? So this interface is nothing, this interface is a blueprint of that class. So whatever implementation we have in this Tesla car class, we are creating this blueprint for that one, right? So this is just photocopy of that. So drive method is there in Tesla car class, window is in Tesla car class. So if I'll paste that one, so see, this drive is the actual implementation. Just assume this one is your Aadhaar card. Let me add someone. So just assume this drive is nothing, this drive is your Aadhaar card, right? So this is your original Aadhaar card. You want to give some document, like someone asked to submit your Aadhaar card, right? So you won't submit your original Aadhaar card to that person. You will do what? You will create a photocopy for that. So this drive, whatever method, whatever drive method we have declared in this interface, it is just a photocopy or blueprint of that that actual implementation. So interface is nothing, interface is a blueprint of that class. Whatever method and whatever method we have created in our class, just we have to declare those methods in our interface, right? So if we want to use this drive, right, we'll not call this Tesla car drive, we'll call which one? Our interface one. So internally it will go to the drive implementation, it will return those values. Got it? So we are not calling that main implementation directly. If you see here, this is our Tesla car. If Tesla car wants to use these methods, right, this is the main implementation, right? So we are not calling this directly, we are adding one layer. So first it will come to this one, and then internally interface will go to the actual implementation, right? So there is one layer, there is one layer here, right? So what is abstraction? To hide the actual implementation. So Tesla car first will go to the interface, then interface internally go to the window. That the main implementation. Got it? What is abstraction? Here we are following that one, right? We are adding one layer. Okay, so in for the security purpose we are using this one. So if you are seeing, you have your house, right? So this is your house, right? So outside your house you have seen like you have some boundary wall, right? For some security purpose you are you have that boundary wall. If so, and this is your entrance gate, this is your, just assume this is your entrance gate, right? So if someone came to your door, right, so first they will cross this boundary, then they will come to your house, right? The same way, if Tesla car wants to use drive functionality in that car, they will go to this interface, then internally interface will connect to this main implementation. You don't have to call this main implementation directly. because you have to hide your main functionality, right? If you are calling someone, you are not writing all the code and then you are calling that person, right? Just you are typing that person number, you are clicking to that call button. That's it. The main implementation available in somewhere else, right? You don't know. So the owner of that phone, that mobile phone, is hiding those implementation, right? The same way, if you are trying to use this drive, brake, window, wheel, gear, music, these type of functionality in your car, the main implementation available in different class, you are using this interface to interact those implementation. Got it? Any doubt on this abstraction concept? Why we'll use abstraction in Java? So this is the reason, like, why Java is secure, because Java is using this abstraction functionality, abstraction feature. So we are hiding our main implementation. This is a simple example of abstraction. We have, like, when we'll go in depth in abstraction, we have many implementation for that. But I am giving you just a simple example for that, right? So we are hiding the main implementation. First, it will go to interface, and then internally it will take that result from this implementation, and they will return it to you. Got it? So any doubt on this abstraction concept? Okay. Now we'll see the program as well, right? So we have created this Tesla car. Inside Tesla car, we have their implementation. So let me show you that, yeah, order also. So you have one interface, you have their implementation class. So just assume there is one class, Amish. Oh no, not Amish. What class we have created? So we have, what is the class name? We have this abstract example. Okay, abstract example. So abstract example wants to use this functionality, right? So it will go to, first it will go to where? First it will go to interface. Interface. Then it will go to where? Then it will go to that implementation. So this is the order, right? That this class will not go to this implementation directly, it will go to this interface, and internally interface will go to their actual implementation. Okay, so this is the order. This is the order. Red, border as well. Okay, so we have our interface. So always, if you are following abstraction concept, first you have to do what? First you have to create your interface. So whatever functionality you want to add in your class, so first you will create their interface, then it will go to that implementation class, and then you will create their implementation. So see, we have created interface here, and we have created our class as well, and in this class you have implements your interface. So don't forget to implement those interface in your class. If you are not implementing that interface in your class, it means you haven't followed that abstraction concept. So don't forget to implement those interface in that class. Okay, if you are implementing that one, it means this interface is now the blueprint of that class. Got it? Now how will you use this interface in this abstraction example class? Earlier we have seen, if we have any class and in different class we have some methods, so what we'll do, we'll create object of that class, and with the help of that object we'll use that, right? So let me give you that. So we have this Tesla car class, right? In this Tesla car we have these methods. So earlier we have seen, if we want to use those methods, we'll create object for this class. missed the new keyword here. Yeah, so we have created object of this class now, obj dot drive, obj dot wheel. So if directly we are creating object and just we are calling that method, right? So this is, so if we are following this one, so this is not the right approach, because we are trying to implement the abstraction. So we are trying to add one abstraction layer into that. So how can we achieve abstraction? With the help of interface and abstract class. So now first we have seen the interface one, right? So now we'll remove this object creation. Now how can you use any interface in any class? Okay, so if we have any class, we'll do what? We'll create object of that class, right? We'll create create, we'll create object of that class and we can use that, right? But when we'll come to interface, you can't create object of any interface. Got it? So we can create object of any class, but we can't create object of an interface. Okay, so how can we use that interface in our class? You can use reference of that class in your interface. Now how can you use that? Right, so you have this I1 interface and your implementation is available in which class? Tesla car class. Okay, so see here, if you are trying to declare any variable, what we'll do? So we have their data type, then we have variable name, then we have value, right? So in num variable, I have declared this 100. Okay, now we'll come to the interface part. So as I said, you can't create object of an interface, right? Then how can you use that interface? So you can use reference of that class in your interface. So just see here, I1 is our interface. Okay, I1 equal to new Tesla car, right? So just we have after like before equal to we have this one, after equal to we have this one. So just compare with this one. What is the data type of this num variable? Integer. What is the data type of this I1 interface? Okay, and equal to we are giving some value 100 into this num variable, right? So as I said, if you are trying to create object of any class, it is doing what? If you have non-static methods, so it is giving memory to that non-static method. That's why we are creating object, right? So after equal to, with the help of new keyword, we are creating object. So we are creating object of our class, but we are giving reference to which one? Our I1 interface. So this is the reference of that class. So we are declaring our I data type is what? I1, but in this I variable we are assigning Tesla car value. So Tesla car reference. So if we are doing this new Tesla car, it means all this drive, gear, window and this music, wheel, brake will come to that interface, right? Now if you'll see, I will do what? I dot drive. Okay, I dot wheel, I dot brake, I dot music and I dot gear. Okay, if we'll run this program now, If you see, we got the output: drive, wheel, brake, music, and gear. So what we have done here? We have given the Tesla car reference to this interface. Okay, so you cannot create like I1 I equal to new I1. Okay, it will give error. Cannot instantiate the type I1. It means you cannot create object or instance of this I1 interface. So if you want to create object, it means you have to give, you have to create class. So so our actual implementation is in which class? Tesla car class. So we are giving reference to our interface. Okay, so we are initializing our interface with this Tesla car. Got it? Because Tesla car contain all the methods. Tesla car contains all the methods that we have in I1 interface, because we have implements those methods in our class. That's why we can give that class reference to our interface. Now, any doubt? How can you use interface in your class? So we have this interface, implementation, and here we have used those methods with the help of interface. So we have called this interface. So just we have called this one interface internally, called this drive, called this window, called this gear, called this music and wheel and this brake. Any doubt on this one? Just refer this diagram once again. We have this Tesla car. We have this main implementation. We have added one layer. We have added one interface layer between of that. Right? Because why? Because we are hiding this implementation. So Tesla car won't be able to see that main implementation directly, because we have added one layer into that. Got it? Why we have introduced this interface I1 here? Hello. If you have any doubt, please ask. I will repeat again. At least say yes or no, then.
No doubt.
Okay, thank you. Okay, let me show you one more example. Abstraction 2. So what is the first process if you want to use abstraction concept, right? So you have created this class. So here you want to use some functionality. What type of functionality? So here we'll see calculator functionality now. Okay, because earlier we have discussed this calculator in depth, right? So we have this calculator, right? We have this calculator. So if you want to add some numbers, so 85 plus 23, just we have typed those number, right? And we'll click to equal to. We got the output 108. How we got that output? Let me create notepad. No, not notepad, sorry. Where is paint? Yeah. So yeah, so you have this calculator, you have typed this number 8523, you got the output 108, right? How we got that output? When you will click to that equal to, they have added those two number and they have returned those, that the actual value, right? So when you click to this equal to, internally they have written some program for that, right? They have written a, like you have entered two number, So just assume this 85 is a variable, 23 is b variable. So internally they have done what? A plus b equal to c. No, not a plus b equal to the result. So 85 plus 23 will get that 108. So internally they have written some code for that, right? So here they are also using that abstraction functionality. Right, in different programming language we have different concept, but syntax is different, but that concept, abstraction concept, is same in everywhere. Maybe they have written this they have created this calculator feature in different programming language, but they have also that abstraction concept. To hiding main implementation, they have also introduced some topic for that. As in Java we have to achieve abstraction we have abstract class, we have interface. So in any programming language, if they have created this calculator, they have their that feature, right? So when we'll click to this equal to, they have internally they have written some program for that, right? So just we are using that program here. We are not writing that program like if we have to click to this equal to, we are writing okay a plus b, we are creating one method, add method, we are passing two argument int a comma int b, then we are returning a plus b, right? We are not writing that program. Internally they have written their implementation somewhere else, just we are using that one, right? So we have created this abstraction to class. Now I am creating one interface calculator. Okay, so this is our interface. So in calculator we have some functionality. So just I am introducing like public and int. So add. Okay, so if we'll call this add method, it will do what? It will add some number. So I'm just passing some argument also, int a and int b. Got it? I'm passing two argument, again public int subtraction. Okay, so this one is addition, this one is subtraction. So if we'll pass two number, they will do what? They will subtract a with b. Okay, public int multiply. So if we'll pass two number, they will multiply that number. Okay, so just I'm adding these three methods in our interface. Now we want to use this addition, this subtraction, this multiply in this class, right? So as we have declared only methods in our interface, right? So in interface only declaration. Okay, blueprint of your Aadhaar card. Okay, Xerox of your Aadhaar card, RATION or blueprint, yeah. So we have to implement, those methods somewhere else, right? So for that we'll create one class. So calculator IMPL. I have created this class calculator IMPL. It means calculator implementation. So if we are creating any class, every time we have to check whether whatever class name we are providing, it is specifying something or not, right? So if we'll give some this one, right? If we'll give some ABCD here, if like I have written this program and I have stored it, if some other person came and they have opened this class, they will confuse like for which purpose I have created this class, right? So if we'll give any specific name, so I have written here calculator IMPL, they will understand. Once they will see that class name, okay, they will understand like okay, this one is for calculator implementation, and I have created this calculator interface. They will see okay, this one is for calculator functionality, right? So once you are if you are creating any class or any interface, so you have to give some specific name that will specify that class or that interface. Like we have created that class or interface for that purpose. Okay, so I have created this interface for some calculator functionality, so that's why I have given this name as a calculator. I have created this class for calculator implementation, so I have given this name as a calculator IMPL. IMPL is shortcut of implementation. Got it? Now what we have to do, we have to implement this calculator in our IMPL class, right? So which keyword will use for implement? We have implements keyword, right? And we have to implement our interface calculator, right? Now it is saying here the type calculator must implement the inherited method calculator and this one, right? So we have one shortcut here as well. If we click to this add unimplemented method, so Eclipse is providing this shortcut. If we click to this one, if you see here, automatically they have added those methods. Manually you can create as well, and they will add that methods directly. If we click to that, I'm again doing Control Z. So see, we have implements that calculator interface in our class, but their implementation is not available in our class, so that's why it is giving that error. So Eclipse is giving some shortcuts, so that's why now you will see if that time, if now if you'll use that notepad, if you write this program, they will not give you this error, right? So manually you have to check whether you have some error in your program or not, right? So that's why we'll prefer some ID. So I have chosen this Eclipse ID to write Java program, right? So if we click to this add unimplemented methods, why it is giving this error? Because we haven't created implementation of this addition, subtraction and multiplication, because we have implement those calculator interface in our class. So we have to add their implementation as well, right? So if you see here, they have added one keyword, they have added one annotation, @override. What is this for? If you'll remember polymorphism concept, what is polymorphism? In polymorphism we have method overriding. So if you see here, whatever method we have declared in calculator interface, their return type, their method name, number of argument, type of argument, if everything is same, that is what? Method overriding. So when we are using this interface and their implementation, that time we are using what? We are using method overriding. The same method we have created in our calculator interface, the same method we have created in our calculator IMPL as well. It means we are following that method overriding here. Method overriding. So this interface implementation is also example of method overriding. So we can achieve method overriding with the help of class and with the help of interface as well. Got it? So if we'll remove this override, now it will work, like, because we have taken help of this we have just clicked to that one and they have added these methods. So that Eclipse ID added that override annotation here. It means we are overriding this addition method, we are overriding this subtraction, we are overriding this multiplication. Copy and copy. Yeah. Now any doubt? How can we implement any interface in any class, and how we are why we are using this method overriding here? Because the same method, what I said earlier, if you are creating any interface, it means it is the blueprint of that implementation class. So this is the blueprint. So if method name is same, method return type is same, method parameter is same, number of argument, type of argument and order of argument is same. It means it is method overriding, right? See here, addition, return type, addition, number of argument, type of argument, order of argument. It is same as our implementation. That's why it is called as a method overriding. Got it? Any doubt?
No.
Okay, I will take it as no. So this is addition. So this is addition method. So in addition we'll do what? We have these two number. So we have to do what? We have to add these two number and return, right? So let me remove this program. Like Eclipse ID added this auto generated method stuff because we have auto generated those methods. So by default they have added this line here. Okay, so here what we have to return? A plus B. So in return we can directly return those number. If you want to do what, like int C equal to A plus B, and then you can return that C as well. But we are wasting this C memory, right? We can directly return A plus B as well. So if you are declaring C, it means in Java memory they are creating some space for the C variable as well, right? So we don't have to waste our memory. So we'll do what? We'll directly return number A plus B. Sorry, A plus B, right? Same in subtraction. What will do? A minus B. Multiplication will do what? A multiply B. Right? So if we'll call this multiplication method, if we'll call this subtraction method, if we'll call this addition method, they will perform their active implementation. So we have just single line of implementation. So this is the simple example of methods. So when we'll go in depth in methods, we'll add more lines of code. It means like just don't assume like if in methods we have only single line of code. In methods we have n number of line of code. Whatever lines we want to add, we can add it. It depends on our implementation. So here we have only addition functionality. We have only subtraction and multiplication. This is a simple example, right? Now we have created our interface. We have implements those methods in our class as well. Right? Now what we have to do? We have to call these methods. Now we want to add some number, we want to subtract some one number, we want to multiply some number, right? So we have this class. Here we'll do what? So how can we use any interface in any class? We'll declare calculator cal equal to. Now we have to give reference of that implementation, right? So new and the class name, right? So we cannot create object of interface. So that's why we have to give reference of our implementation, right? Now calc dot add. So if we'll pass 100 and we'll pass 50, they will add these two number. Okay, if we'll call calc dot subtraction 150, and if we'll call calc dot multiply 150, right? Now if we'll run this program, see, oh wait, okay, so this why we didn't get any like 100 plus 50, 150, 100 minus 50, 50, 100 into 50, that why we didn't get that output here? Because we have called that method. That method is returning that number as well. Why we didn't get that output?
Return type void.
No, return type is C, integer, return type is integer, return type is integer. We haven't added any sysout system.out.println statement. That's why we are not getting that output, right? So if you want to print something, we have to add that sysout statement. So inside sysout statement, inside the sysout statement, we have to call these methods. All right. because our method is returning something. That's why we have to call our method inside sysout. If our method directly printing those lines, right, that time we'll directly call that methods. Okay, if we'll run this program, now we'll get the output. So see, 100 plus 50, 150. We have passed these two number, right? 100 and 50. We have passed 100 minus 50, so then we return 50, and 100 into 50 will got this 5000. Any doubt on this interface example? Why we'll use interface? How can we use interface? Any doubt on this one? Good. So that's it for today. Tomorrow we'll discuss the abstract class one, like what is abstract class. So interface, we have seen some example for that. Tomorrow we'll discuss like what is abstract class, how can we use abstract class. Then we'll see what is the difference between interface and abstract class. When you have to use interface, when you have to use abstract class, right? So I'm just sending this program also. I will send this sometime. Yeah. So that's it for today. Thank you for joining. Yeah, have a good day. Thank you.